Granularity of a data refers to the level of detail in a given data. Let's understand this using a data that is generated in a superstore. Whenever we purchase groceries or products in a supermarket, we get a computerized bill which contains price, quantity, tax, etc. for each item that we buy. This level of data is what will be stored in the centralized data warehouse as well. For a single customer, multiple records will be stored based on how many products they buy. If a customer has bought 10 products, the system will insert 10 records or 10 rows to the database. Likewise, for every purchase from a single customer, data will be available at product or item level, which is called as the granularity of data. Let's consider another example from a wearable device, which continuously monitors the heartbeat rate. In this scenario, the device might record heartbeat rate once in every minute or once in every hour. Here, the data will be either minute wise or hour wise. Likewise, every data will have its own granularity. It could be at product level for a supermarket data, or it could be a minute level for a wearable devices, whereas for a stock market prices, data might be at daily level. In education field, data might be at student or subject level. It is very important to understand the granularity of the data, because for many questions that we try to solve or plot in a visual, we need to pick the appropriate level of data. In the superstore example, if the store manager decides to analyze the top 10 customers on a particular day to roll out some offers, he has to aggregate the data from product level to customer level as shown in this particular table. Here, every row represents the total purchase amount of a customer along with number of products they bought. This table is a result of aggregation from the raw data, and by doing so, we have changed the granularity of data from product level to customer purchase level. For the same superstore, if the stakeholders decides to analyze the revenue made throughout the month, the analyst will aggregate the data and compute day-wise total purchase. Here, the granularity of the data is at daily level. The advantage of high granular data is that it will help to answer many questions from different levels of stakeholders. Depending upon the question, we need to pick the right level or the granularity of data by performing some data operations. The disadvantage of high granular data is that storage volume will drastically increase and it will affect the performance or the speed of analysis. But luckily, the cost of high performance systems and storage space has become very cheap. This encourages organizations to store data at high granularity so that there will be one source of truth, and anyone who wants to perform data analysis can either filter or transform to pick the right level of data. In this section, we are going to learn about different data types and understand its importance in data visualization. Once we have identified the granularity, the next step is to classify the individual columns in the data. Typically, the columns or the variables in a data is classified either as quantitative or qualitative. Though this is a very crucial classification for many analysis and machine learning algorithms, for data visualization at least, it is ideal to classify them further into many different types. Let us understand them one by one. Firstly, those columns in which most of the values are repeating are considered as qualitative or categorical columns. Columns like country, employee name, product name, etc. are typical examples of categorical columns. Secondly, all numerical columns are considered as numbers or quantitative columns. Columns like product prices, revenues, volumes, runs codes are typical example of quantitative columns. Important numerical columns are also called as KPIs, which stands for key point indicators. KPI plays a vital role in data visualization because most of the analysis that we do will be in and around this particular KPI metric. The next type is date columns, which I guess is straightforward to understand. Typically, we'll have purchase date, project end dates, date of birth, issue created date, etc. Even if you have partial dates, it can be considered as date columns. The next data type is location columns. For example, if you have state name, country name, pin codes, latitude or longitude, All these can be considered as location columns. Finally, we have text columns which contain many words or sentences in every row. For example, customer reviews, product description, tweet messages, etc. can be considered as text columns. These are not the exhaustive list of data types. There are many more special types of columns. For example, phone numbers, email IDs, etc., which can be separately categorized. Also, a single column can be classified under many data types. For example, the state column could be considered as both categorical and also location, whereas a name column could be considered as categorical or as a text column. Please note that for many other columns, we might tend to ignore them for our analysis. For example, ID columns, which is mainly useful while we join or merge the data frames, is not going to be useful for our data visualization. For any analysis that we choose or for any visual that we plot, it depends mainly upon these data types. Let us take an example. Using location columns like state name, country name, etc., we can perform geographical analysis using maps. Whereas on the other hand, if you feel that there is no date columns, obviously we cannot perform any types of trending analysis. Hence, inclusion or exclusion of any analysis or visual mostly depends upon the type of variable we have in our data. Let us take few data sets and understand its granularity, and also we will try to classify the columns into different types. In this data set, we have runs scored by every batsman in their individual one-day international matches. We have players from all the countries and data is available from 1971 to 2011. Let us pick one row and understand the different columns. The first column is the country name. The second column is the player name. In the third and fourth column, we have runs and strike rate scored by the player in a single match. The next column indicates the date in which match was played. Next to date column, we have ground column in which the matches was conducted. Next to ground column, we have versus column. This is the name of the opponent team. Finally, we have URL column which lists the URL from which the data is scraped. Based on the different columns, we can understand that the data contains match level player runs, which is also the granularity of the data. Our next step is to classify these columns into different types. Under categorical type, we have columns like country, player, ground and versus. It is up to the analyst to consider or ignore match date under categorical columns. Under numerical columns, we have runs and score rate. For our further analysis, we might be considering runs column as a KPI. Under the type dates, we have match date. Under location columns, we have country, ground and versus. Remember, versus indicate opponent, which is also a country name. If you carefully observe all the columns, we do not have any proper text column, but an analyst might choose to do some text mining analysis using player name. Since URL column cannot be categorized into any of these types and it is also not such useful for analysis, we can ignore this particular column. Let's pick one more data set. This data set is about parliament elections, which contain details about total votes secured by every contestant in a particular parliament constituency across different states in India. Likewise, we have details from first parliament election till 2009 election. Let us pick one row again to understand the columns in detail. The first column is the year column in which parliament election was conducted. The second and third column represents the state parliament constituency respectively. Fourth column is the candidate name. The next few columns represents gender, party to which he or she belongs to, and their age at the time of contesting. Vote columns represents how many votes a particular candidate has secured, whereas the elector column indicate the total number of population in that particular constituency who are eligible for casting their votes. And finally, we have winning position of the candidate in that particular election. Like previous example, let's classify the individual columns in this particular data set also. Under categories, we have columns like year, state, PC, sex, party, category and position. Again, it is up to the analyst to pick name as a categorical column. Under numerical columns, we have age, votes and electors, whereas under date types, we have year column. Though it is a partial date type, we can still consider this particular column under date types. Columns like state and PC can be considered as location columns. No proper text column is available, but if needed, we can consider name as text column, and that again depends upon the analyst who is working on this particular data set. I hope by now you are comfortable in understanding the granularity of data and classifying individual columns into different types.